Since the earliest days of radio astronomy, humanity has been listening to the cosmos, eagerly hoping to catch a signal that would prove we're not alone in the universe. Welcome to Science with Lou, where we explore the fascinating mysteries of the universe. In this video, we dive into the intriguing world of interstellar signals, potential contact with extraterrestrial life, and the profound implications such an encounter would have on our planet. So let's embark on this cosmic journey together. Our quest began in 1937 when American amateur astronomer Grote Reber constructed the first functional radio telescope. Reber's homemade telescope allowed him to map the radio structure of our Milky Way galaxy, identify sources of radio waves beyond our galaxy, and make crucial observations that contributed to the discovery of non-thermal radiation. Before we delve further into the mysteries of interstellar signals, it's important to understand the basics of radio waves. These waves are part of the electromagnetic spectrum, much like light waves, and they travel at a staggering speed of 186,282 miles per second, or 300 million meters per second. Now you might be wondering, why is there a need for radio telescopes? Well, this takes us to the concept of SETI, the search for extraterrestrial intelligence. For decades, SETI has been scanning the heavens for radio signals that could potentially originate from advanced civilizations like ours. Over the years, we've picked up some mysterious radio signals, and one of the most famous among them is the enigmatic WOW signal. The Big Ear Radio Telescope, also known as the Ohio State University Radio Observatory, was a significant instrument in the field of radio astronomy, located in Delaware County, Ohio. It was a Krauss-type radio telescope named after its inventor, John D. Krauss. Construction of the Big Ear began in 1956 and was completed in 1961, with its first operation in 1963. The main reflector of Big Ear, known as the flat reflector, measured approximately 103 meters by 33 meters, providing it with the sensitivity equivalent to a circular dish measuring nearly 53 meters in diameter. The observatory achieved the Ohio Sky Survey in 1971, and from 1973 to 1995, Big Ear was utilized for the search for extraterrestrial radio signals, making it the longest-running SETI project in history. On August 15, 1977, a remarkable radio signal was detected from outer space. Dubbed the WOW signal, it was captured by the Big Ear Radio Telescope at Ohio State University's Perkins Observatory. Dr. Jerry R. Amon, an astronomer working on the SETI project, stumbled upon this unusually strong and narrow-band signal that lasted exactly 72 seconds. Amon was so baffled that he circled the data on the printout and wrote WOW in red ink, which is how it got its name. What makes the WOW signal even more captivating is its frequency, 1420.4 megahertz, which falls within the hydrogen line, a frequency known for its potential for communication by extraterrestrial civilizations. In radio astronomy, the hydrogen line represents a unique wavelength of radio waves emitted by hydrogen gas in space, a kind of cosmic fingerprint. The WOW signal has remained one of the most potent signals ever received, yet its source remains a mystery. In 2017, Professor Antonio Paris of St. Petersburg College proposed that comets 266 P. Christensen and 335 P. Gibbs were responsible for the signal due to their hydrogen gas clouds. However, not all astronomers, including Amon, agree with this theory, as the signal did not repeat and appeared for only a short time. Moreover, the Big Ear telescope had 2 feed horns, and if it were a comet, Amon would have seen it twice, each lasting 72 seconds within a minute and a half. However, Amon is not convinced it's of alien origin either. the WOW signal remains a mystery, leaving us to wonder who or what transmitted it. Now, as captivating as the WOW signal is, it's not the only mysterious transmission from space. In 2020, a research team examining data from the Australian Square Kilometre Array Pathfinder, or ASCAPI radio telescope, stumbled upon something truly puzzling. Out of the 2 million objects they identified, one in the center of the Milky Way galaxy had them scratching their heads. This unidentified object emitted powerful radio waves and demonstrated an irregular pattern. Even more perplexing was the fact that it couldn't be seen in X-ray, visible or infrared light. Furthermore, the radio signal mysteriously disappeared after months of observation with 2 different telescopes. A year later, the signal resurfaced and vanished again, cementing the object's status as unlike anything the research team had encountered before. Scientists believe that this discovery might belong to a category known as galactic center radio transients, or GCRTs, but these objects are still not fully understood. However, before we jump to conclusions about these signals originating from aliens, it's crucial to consider that technological signals from advanced civilizations would likely operate on narrower frequency bands, unlike the GCRTs. These could be neutron stars, pulsars in close orbit with one another, or dying pulsars emitting irregular radio bursts. To shed more light on these cosmic mysteries, a new telescope called the Square Kilometre Array is under construction in Australia and South Africa and is expected to be completed by 2028. The SKA represents a remarkable technological leap in our quest to unravel the universe's enigmas. Comprising thousands of radio antennas spread across vast expanses, the SKA will have an unprecedented collecting area equivalent to a square kilometre, allowing it to capture and analyze radio waves from space with unparalleled sensitivity and resolution. This cutting-edge instrument holds the promise of unlocking some of the deepest secrets of the cosmos, from understanding the nature of dark matter and dark energy to shedding light on the origins of the universe and its evolution. As the SKA comes to fruition, it is poised to revolutionize our understanding of the universe, offering fresh insights into the mysteries that have perplexed astronomers and astrophysicists for generations. It might hold the key to unlocking some of these secrets. Now you might be wondering, with all this talk about signals from outer space, have we ever received signals from extraterrestrial civilizations? The answer is yes, we might have. In a surprising turn of events, scientists recently discovered an object that has been sending radio signals toward Earth since at least 1988, and we had no idea about it until now. For the past 35 years, we've been experiencing bursts of energy from an object located 15,000 light-years away. These bursts vary in intensity, occurring approximately every 20 minutes and sometimes lasting for up to 5 minutes. Initially, scientists suspected the signals were coming from magnetized stars with incredibly powerful magnetic fields. To put it in perspective, that is like a super strong magnet halfway to the moon that is powerful enough it could swipe the data from your credit card. Magnetars can crack and release energy in powerful bursts of X-rays and gamma rays, which we can detect from Earth. However, there's also the possibility that these signals could originate from an extraterrestrial civilization trying to communicate with us. But we need to consider other possibilities. Our journey into understanding extraterrestrial signals takes us down the path of considering what it would take for us to detect such signals from distant civilizations. The first challenge is the frequency range. The waterhole frequencies, ranging from 1420 to 1662 megahertz, are the most likely channels for communication. However, there's no guarantee that other civilizations would choose these specific frequencies. Signal strength is another crucial factor. To detect a signal across interstellar distances, it would need to be exceptionally powerful or aimed directly at our solar system. Broad beam transmissions lose strength rapidly as they travel through space. Timing plays a significant role as well. Space is vast, and the timescales involved are immense. An advanced civilization would need to transmit its signal at a time when we possess the technological capability to receive it. If their transmission happened too early or too late relative to our technological advancement, we might miss it. Furthermore, radio transmissions from Earth have not ventured very far into space. While the idea of aliens intercepting our radio signals and planning an invasion is a staple of science fiction, the reality is quite different. Most of our radio signals have traveled only a small distance from Earth. Additionally, consider that the speed of light imposes a time delay. When we observe stars in the night sky, we are essentially looking into the past. For instance, the star Sirius, which is relatively close at 8.6 light-years away, allows us to see light that has traveled for 8.6 years. Gazing at more distant objects means looking even further into the past. Now, if an extraterrestrial civilization 65 million light-years away could observe Earth, they would be witnessing our planet during the time of the dinosaurs. However, they wouldn't hear any radio signals from us. This means that even if they intercepted our signals, it's highly unlikely that they would reach us in time for a response unless they possessed the ability to manipulate space-time using wormholes, which is purely speculative. To make contact with another planet far away, radio signals might not be the most effective means of communication for an intelligent civilization. Sending signals into space without knowing the intended recipient could be problematic. A more advanced civilization might choose not to announce their presence and could be silent observers monitoring us from afar. Before we delve deeper into the consequences of encountering aliens, be sure to hit that like button and subscribe to our channel so you won't want to miss the thought-provoking discussions ahead as we explore the mysteries of the cosmos. Now let's continue. While it's intriguing to contemplate how extraterrestrial civilizations might contact Earth, it's essential to consider the consequences of such an encounter. Contact with alien beings would undoubtedly be one of the most momentous events in human history, with far-reaching implications for our world. First and foremost, it could foster a sense of global unity. The realization that we are not alone in the universe could lead to increased cooperation among nations and a reduction in conflicts. However, it could also necessitate the enhancement of Earth's defenses in preparation for potentially hostile interactions with advanced alien civilizations. One potential threat to humanity is the risk of alien diseases and their impact on Earth's ecosystems and human health. Just as in H.G. Wells's War of the Worlds, a microorganism could pose an unforeseen danger. Moreover, contact with aliens could challenge traditional religious and philosophical beliefs. Some religious doctrines might require reinterpretation or adaptation to accommodate the existence of extraterrestrial life, while others might vanish entirely. On the positive side, contact with aliens could lead to mutual benefit. If the extraterrestrial civilization is willing to share their technology, it could result in rapid advancements in science and technology on Earth. Access to new energy sources, medical breakthroughs, and a deeper understanding of the universe could be within our reach. As we ponder the possibilities of contact with advanced civilizations, we invite you, our viewers, to share your thoughts. Do you believe we will ever receive a signal from an advanced civilization? If so, how do you think such a contact might play out? Your comments are valuable, and we look forward to hearing your insights. That concludes our journey through the fascinating world of interstellar signals and potential contact with extraterrestrial life. Thank you for joining us on Science with Lou, and don't forget to hit that like button and subscribe for more thought-provoking content. As we venture further into the cosmos, we'll continue to explore the mysteries that await us. Stay curious and keep exploring.